Hello, it's Keith here, and this is lesson 33 of the simple series of my Z8 assembly programming tutorials, and we're looking at the MSX2 again, and we've got a Chibiko bitmap on the screen. Chibiko being the mascot of my website, so we can see it moving around, but this version has been upgraded because we had a simple version before. This version can now do sprite clipping, and our sprite can go partially off the screen. Now, we've been writing this example on a variety of different systems, and it works roughly in the same way on all of them. The idea being we can port our games between them a little bit more easily, but there are some differences in the way this one works because this system, the MSX2, uses a VDP, so we're not transferring byte data by ourselves. The actual system is doing the work for us, and we're also using two screen buffers. So basically the way that the system works on the MSX is we have a virtual screen which is 256 by 1024 pixels. Our actual screen is 256 by 192, and so we select an area within that virtual screen to show to the screen. And so one of our screen buffers is at 0,0, and the next one is at 0 across and 256 down, and that's the second screen buffer. Our sprites themselves are further down at 512 pixels down, so 0,512. And so what we're going to do is we're going to select an area of that off-screen sprite and then transfer it to the visible screen in the correct position. A little bit tricky. That's what we're going to do though. Now, before we go into that, what we need to do first is discuss some of the theory, because we've got some technicalities that we're going to see in our code. So let's go over to the projector and let's see the example of the theory of how we're calculating our coordinates. Now, we're working on an 8-bit system, and so we're going to be using a single byte for our x and y coordinates. But although that works fine with our 256 by 192 screen in theory, when we're actually cropping, we need coordinates that are completely off the screen. So if our x coordinate goes up to 256, there's no off-screen area. So we're going to use an alternate logical coordinate system where basically one logical unit is 2 physical pixels, and this allows our 256 by 192 screen to become a logical screen of 128 by 96, as you can see here. And so this is going to be in a larger area, and this is going to allow us to have off-screen areas. So basically 0,0 would be off-screen, 64,80 would be the first visible pixel, and 192 by 176 would be the last visible pixel. And so if we had our Chibiko here, this dark part would be not drawn, and this light part would be in the bottom left area of the screen. So that's how we're doing things. And as I say, 2 physical pixels equals 1 logical unit, and it works really well on all systems. Some systems can't sort of horizontally draw in individual pixels either. This system does have limitations with regards to that, and so a lot of systems that actually work in pairs of pixels most efficiently anyway, at least horizontally speaking. Vertically, most can do individual pixels easily, but as I say, it's a limitation like that is not an issue for 8-bit systems, so I think that's a really good way of working. Now let's go over to our blackboard and let's discuss the theory of how we're calculating our crop. And it's the same every time, but this time the algorithm's a little bit different, as I say. So basically, if we imagine that this is our screen here, it's somewhat square today for some reason, but it doesn't matter. And this is our sprite. So there's our sprite. It looks quite happy for some reason. And our sprite is moving around the screen as usual. Now, it's going to go off the screen at some point, and we're going to have to calculate things. Now, in the past, we've had to calculate the number of bytes we need to remove from the top of the sprite, but in this case, we don't do that. We just calculate the amount of pixels that we need to skip at the top. We change the y position to 0, and we change the height, of course. So we're not skipping pixels in this case as such. We're counting the amount to remove instead in lines. So we're going to need to use that to alter the starting draw y position, because as I say, we're copying from the invisible area of the screen down the bottom off the screen to the visible area, and that's how we get our sprite to the screen. If you don't know how the sprites work, please see the other simple series examples, the simple bitmap example I've done before on the MSX2. That will go into more detail. Now, if we've gone off the bottom of the screen, we don't need to remove anything from the sprite itself. We just change the height, and that will work just fine. Now, on the left-hand side, again, we need to calculate the amount we need to skip from the left-hand side, and we also need to change the width. And again, because we're using the VDP this time, we don't need to skip anything after each line. The VDP is doing all that work for us. So there we go. And when we're off the right hand side, again, all we need to do is we just need to change the width of the sprite, and that will do the job for us. And as I say, the code does need to cope with corner cases, because that will happen, and it does indeed do so. Okay, well, let's go over to our code and let's take a look. Right, so here is the code for today's example. MSX2 bitmap clipping, we've got the definition of the minimum visible coordinates in logical units and the width and the height of the screen in logical units, and we've also got a byte which is visible screen bank in memory, and this is going to be a 1 or a 0, and this is going to be effectively y line equals 0 or y line equals 256, and that's the start of the visible screen, and that's for our double buffer. Well, we might as well just take a look at that first. So how do we do our double buffer? Well, we've got our page flipping routine here, so we're waiting for the VDP to be finished. And then what we're doing is we're loading that byte in. As I say, it will be either a 1 or a 0. We're shifting the bits to effectively be in the where the S bit is there. That will be the 1 or the 0 of the screen bank. And all of the bits are being set to 1 here. We're sending that to the VDP control port. And then we're sending that to register 2. VDP register 2, the plus 128 is to tell it we're changing a VDP register. And that is setting the visible screen. So that is all we need to do to change the visible screen. And then what we're doing beyond that is we are changing our draw routines, because those use the visible screen bank as the Y line of the visible screen effectively. So either Y line 0 or Y line 256. So that's what we're doing. Now, our draw player routine, as this is based, as I say, on the previous simple series example where we were just moving a sprite around with the joystick. Width and height are now 24 by 24. The sprite is 48 by 48, but as I say, 2 pixels equals 1 logical unit, so it's divided by 2 there. Now, IY on most systems will be the bitmap source, but on this one it's not, because of the way the difference in the way it works. So on this system, IYL is the amount to remove from the top in lines, IYH is the amount to remove from the left in pixels. So we're going to be using those to calculate our corrections. Okay. And of course, we're using VDP commands to do the transfer. We're getting the VDP to do all of the data copy work, because that's the fast way of doing things. Here is our do crop routine. It's mostly the same as before, as I say, just with a few slight tweaks. So B and C are our X and Y position in logical units. H and L are our width and height in logical units. And IY is not the source bitmap. That's a mistake. That shouldn't be there. So IY is the amount we're going to need to remove, and that will be set by the end of this routine. So DE is a temporary pair of variables that's going to be used for our calculations. And so what we're going to do first is we're going to load in the Y position, and then we're going to subtract the minimum visible Y position in logical units. Now, if we imagine that this is our sprite, if our sprite is somewhere like this, when we do that, the Y position will go negative. And so if it's not gone negative, we're just going to skip the next bit. But if it has, we're converting that back to a positive, and we're comparing it to the height of the sprite. Now, if the Y position is greater than the height of the sprite, then we're off the screen somewhere like that. And so in that case, we're going to jump to all off screen. And this is a routine that just simply gives up. It sets the carry flag and returns, because our calling routine, if the carry flag is set, will just give up and draw nothing. That's going to save some time. Otherwise, we're storing this in E. This is the amount to remove from the top, and we are setting the Y position to 0, because we're going to start drawing what we are going to draw from the very top of the screen. Okay, now we're adding the height of the sprite, and we're subtracting the height of the screen in logical units. And what we're doing here is we're seeing if the sprite is partially off the bottom of the screen. Now, if we're partially off the bottom of the screen, the carry will be clear. So in that case, we are going to have to continue, but if the carry is set, then we aren't, so we're just going to skip the next part. If we're partially off the bottom of the screen, we're checking if it's the entire sprite. Again, maybe we're just somewhere down like this, nothing to draw, we would give up. So we store the amount removed from the bottom in D. Okay, we now add those two together, and if that's not 0, then there is something to crop. So we would skip if it is 0. Otherwise, we convert it to a negative, and we add it to L, which is the height, and that's the new height with the amounts removed from the top and the bottom. We then convert E from logical units to pixel lines, and we store that in IYL. That's the amount of lines to remove from the top. We're now going to do the same for the horizontal positions. So we're clearing DE, we don't need the old values anymore. And we're taking the X position now, and we're going to do the exact same for the horizontal axis. We subtract the minimum X position, and again, if we are somewhere like this, this is going to cause it to go negative. Otherwise, well, there's nothing to do, so we would just skip the next part. We then convert that negative to a positive if we need to do a crop. We compare to the width. If it's the entire width or more, we give up. Otherwise, we store the amount to remove from the left in E, and we set the X position to 0. Okay. Now we do the same for the right. We add the width of the sprite and we subtract the width of the screen. Now if that has caused a carry, then we're entirely on the screen, otherwise we must be partially or entirely off the screen. So once again we compare to the width of the sprite, and if it's the entire width of the sprite or more, well, we give up. Otherwise we set the amount to remove from the right in D. Okay. So we take the width, we subtract those two, and then we set the new width, that's the width of the sprite. We then take the amount removed from the left and we convert it to a number of pixels by doubling it. As I say, it's in logical units at the moment, so we double it into pixels. And then we double some more things. We double our X and Y position, our width and our height, converting them to pixels. Now, we could have done this possibly earlier, but I always do this at the very last stage. As I say, this routine is converted from each system, so most of it is the same. Final thing we do is we clear the carry by doing an OR A and we return. Okay, so this routine is being called by the draw play routine with this do crop here, and if the carry is set, then the sprite is off screen and we return. Now we're going to use this VDP HMMM via stack. What we have to do to use this is we have to push various entries onto the stack before we call it, and it's a sort of generic routine I use. Basically what it does is it puts a variety of entries onto the stack, and then it calls the HMMM with HL pointing to the stack pointer, and this uses a sequence of out I commands to transfer that data from the stack to the VDP port, and it executes the VDP command, and then it resets the stack accordingly at the end. This is basically so that we can transfer a bunch of commands quickly from memory, but we don't need to allocate any memory within RAM. We're just using the stack as a temporary RAM store effectively, so that's what that does. Now to use this, we just need to set a variety of registers to the correct values. We need to set IX to the X source. That's the X source off screen. The sprite has been transferred there previously. IY is the Y source, so that's going to be 512 or more, because as I say, it's at the bottom of the invisible area of the second screen buffer. First screen buffer is at Y equals 0, second one is at Y equals 256. We then set the destination, which will be somewhere on the visible screen. The Y destination will be also on the visible screen, but that will have either 0 or 256 added to it, depending on which screen buffer we're drawing. And the width and the height are the final width of the sprite after they've been cropped, and the X source and the Y source will have to have any parts removed from them if the sprite is being cropped on the left or the top. So if it's like that or like that, we would need to do some cropping there, and so we will do that. Okay. Now there's a bit of juggling here because the IY pair of course do actually have the amount removed from the top and the left when this is executed, so you'll see some shifting around there. Now what we're doing first here is we are calculating the X source. As I say, we're having to basically remove anything that needs to be cropped from the left hand side, and we're taking that from IYH here. Now the sprite itself, the bitmap data, is at the far left of the invisible area, so that would start from 0, but we do need to do any cropping required. Now IY is the Y source, and we're setting the high part of that to 2 because basically we're starting from line number 512. That's where the sprite is in the invisible area. The low byte will be whatever cropping was required. So IYL will either be 0 or some amount to crop. So we're not doing anything else with IY there. Now what we're doing next is we are setting the X destination here. We're transferring that from B here, but that needs to be in HL in the shadow registers when we call the VDP HMM via stack. If you were using a different routine, of course, you wouldn't need to use the shadow registers here. This is just the routine I use for convenience. We're then loading in the Y position from C here, and this is going to be in the DE pair. Now the E part, the low byte, is the actual Y position on the screen, but the high byte is either going to be a 0 or a 1, and the 1 will be setting it to line 256 onwards, and we need to set that when we're showing that second screen buffer. So that's why we're loading in from the visible screen bank and setting the high byte of the DE pair there within the shadow registers. So there we go, that's what we're doing there. We're then setting H and L to the width here. D and D are the height. Now D just needs to be set to 0. E will be the correct height for the sprite here. And so that is the last of the variables that we need to set here. And then we're just running this routine, which will show the sprite to the screen. Now, as I say, if you need to know more about how you can use these VDP commands, I do have an entire tutorial where I went over every single VDP command as an example and showed how they all work. The final VDP command, which I'll just give a very quick honorable mention to, is the CLS routine. So where is it? Here it is. So again, this is using a VDP command. It's a different one. This one is doing a block fill of a single byte here. So the single byte is 00 to black out the screen here. Screen is 256 by 192. The X position is 0 and the Y position is either 0 or 256, depending on the visible screen bank again. So that's how we're doing that. So there we go. That's all we're covering today. Now, as I was saying, you can go to my website and download the source code and you can use it in any way you can benefit from. You're welcome to do so, as I was saying. Now, if you've liked what you've seen, please like and subscribe. And as the advert just said, you can buy my book if you haven't done so. That's a good way to help support the channel. Anyway, hope you've enjoyed what you've seen today. Thanks for watching and goodbye.